Hello guys, uh, hope you're all doing fine. So I'm from Samvav Labs. So I'm currently instructing the data science and data analytics course at Samvav Labs. I'm Abir. So I get a lot of requests from students that to let us understand what is the roadmap of data science, how to pursue data science, especially in the 2024, where there are numerous amounts of generative AI and LLM options. So today I would be sharing you the entire roadmap how to learn data science in 2024. So if we see the total history of data science, it has been updated a lot in the recent years, and that has been due to the generative AI introduction and various aspects that came out of generative AI. So I would be covering the traditional learning methods of data science as well as the modern techniques that we should learn along with the traditional methods. So this is the overall data science cycle that we should know before of starting any data science training or any learning any data science technique. So in this data science life cycle, we first determine the business understanding. So whatever project it may be, let it be medical project, let it be some financial project, let it be some agriculture related project. So our main purpose of starting a data science analysis or data research is for why are we doing that project or why are we committing that project. So for that, this the business understanding or the case understanding is very important. So once we determine that business understanding, we look for collecting data around all those business aspects. So let's say we are working in a medical field and we want to understand why at a particular area people are having cancer. Is it due to genetic issues or is it due to food or is it due to anything other aspects? So what we would look for is the data of those medical patients having cancer over that particular area. So once we have that data, we can further go for the analysis. So this data, this mining out the data itself is a large topic. Normally, this data we get from industries. So the working professionals who are working in big tech companies or in a data analyst or data scientist role, this data comes out of the industry sales data or the kind of data the industry is working on. So that mining part is reduced in much of these big companies, but in some small companies where customer segmentation, sales predictions, and marketing predictions, all those things needs to be done. There is a huge amount of mining task that is required as well. So this mining task and all those data acquisition and understanding comes into the second process after business understanding, as you can see in this life cycle process. And once we receive this initial data set or initial data source, then we start our analysis or pre-processing. So first we do pre-processing, that comes in the data pre-processing stage, and then on we go to the further processes like data exploration, what we call as EDA, explorative data analysis. So before moving on to the explorative data analysis, our data should be cleaned, it should be wrangled, it should be uh, it should be not equipped with any null values. We should remove all those null values and any kind of inconsistencies that my data has. I have to remove that so that I can put my data in a structured, consistent format. Then only after I can further move into the explorative stage or explorative data analysis. So this is the second stage. So this second stage has two parts. First part is the data pre-processing, and the second part is the EDA. Now we sometimes deploy statistical methods in this EDA or graphical methods in this EDA. So it is very important to understand the statistical aspects of data as well. So in the statistical aspects, we will be covering various statistical analysis, probabilities, and some arithmetic matrix related uh, problems as well. And finally, we will be using how can those probability based statistical concepts or matrix based arithmetic concepts can help us in further EDA or analysis of the data. And in most of these cases, this after this EDA is done, this EDA is not left alone. We go to visualization of those EDA or preparing a report, and most of the data analytics role ends upon here. Data analytics does not move any further, and visualization is the point where business analyst or data analytics role employees stop, and further the work of machine learning engineer and deep learning engineer starts. But in the data science roadmap, we would be covering the entire uh, processes, because our target is to become a wholesome data scientist. So I would be coming to this further stages. Let us a bit dive into the deep dive into the these stages that I've already told you. So the first stage that I told you, that is data pre-processing, where pre-processing and further statistical concepts we use to do EDA, we would be learning Python programming over here. So this initial 1 month commitment of Python programming is very important, because Python is that language where most of the libraries is useful for data science, machine learning, and deep learning. So no other programming language has such large amount of library set which can be useful for data science, machine learning, or deep learning. That's why we always go for Python in most of the cases. But yes, we also use other coding language as well. It is not restricted to Python. So in this initial 1 month of our learning roadmap, we would be learning Python to the fullest. And here what we would be learning is we would be learning data structures, various data science analysis techniques with NumPy, Pandas, visualization techniques like Matplotlib, Seaborn, and many more. So after we learn all these basic aspects of Python, we would be using these basic aspects in performing EDA. And further, once we are at a stage where EDA is done, we would be moving forward for feature engineering and further deployment of our models, that is machine learning and deep learning models. But with all for all the stages, Python is the very crucial and important aspects. That's why on the very first month we would be learning Python at the fullest. Second, once we are equipped with all the Python knowledge, as we said, that statistics is a very important part in our EDA or analysis, and we would be moving forward for the various statistical concepts like probability, inferential statistics, descriptive statistics, which I would be covering in detail in the next videos. So once the statistical portion is done, we would be again equipping or deploying Python to do the EDA. So we would use the statistical concepts and the Python basic programming concepts to do the EDA and visualization. So once we are at this stage where we have done the analysis and we have showcased this analysis in the form of visualization, which we also call as data visualization, We use this analysis to further do something what we call as feature engineering. Now, why this feature engineering is important? Because we are doing data science, or we are moving forward at a stage where we can make our process of the system or the application that we are working on more automated, and hence we want to deploy machine learning and deep learning. Not only automated in some of the tasks to make the predictions more accurate, we deploy machine learning and deep learning, since with statistical concepts and our human predictions there are inconsistencies, hence we move forward for this machine learning and deep learning. Now, why feature engineering? Because feature engineering makes the data, or the data whatever we have, or the data set whatever we have, it makes it ready so that we can put this data set into machine learning or deep learning applications. So the whole idea of feature engineering is making the data set ready for machine learning and deep learning applications. So what we do here is not only EDA, not only data pre-processing, but also some normalization and standardization that can help in better machine learning predictions or better machine learning accuracy. So this is a wholesome topic in all, and we would dedicate almost 2 months for this feature engineering, because this feature engineering not only consists of the statistical and EDA, but it also comprises of few insights into how should we do the machine learning and how should we plan the machine learning. So this is a very important stage of our roadmap, and we would be deploying almost 2 months for this. Next, once we are done with this feature engineering, as I said, the final outcome would be the techniques to perform statistical analysis and get familiar with all the concepts which will be important for machine learning. Once we are done with this EDA, we would be slightly taking a break, and we would be learning all the databases, because this database learning would be very important for our MLOps or data ops. Hence, we would be learning these databases also in the middle, because what happens is at a stage of learning this data science and all the feature engineering, machine learning and deep learning concepts, we tend to ignore this concept of databases, but we will be taking the SQL and NoSQL forms of database into our learning, which is very important for the present industry workings and your job, and to apply as a job for your data analysis or the role for data scientist. So we'll be learning some NoSQL like MongoDB, or some SQLs like MySQL, Apache Cassandra database. Once we are familiar with this database, why we are learning this database? Because this is very important for our MLOps. We have to nurture with the databases. We have to modify the databases on and on again. Hence, this we have to learn before we move on to the machine learning or further deep learning stages. So once we are done all this with all this 40% of the task, we would be then moving towards the machine learning and deep learning stage. So machine learning is the most interesting part of data science, because here generally comes the insight of how the model should look like, and once we know all the models, then we can choose which models would be good for our data set, and further we can deploy that model. Now, by model, the model term can seem quite unfamiliar to you, but machine learning has two techniques, that is supervised and unsupervised techniques. And in this supervised and unsupervised techniques, supervised by the term, as you can see, it is supervised. There is a supervisor to it, or there are some labels to the dataset. And by unsupervised, I means there are no supervisor to it, or there are no labels to the dataset, And for both of these techniques, we have separate machine learning models. This is very important to understand why each model and what is the working of each model. How can we tune each model to the best way? What are the parameters for each model? Once we understand all these things, then only we can deploy our data set into the machine learning actions. So this machine learning we will be taking a total of 1 month, and this is the very serious 1 month that we will be putting in, because this 1 month will not only uh, cover all the things that we'll be learning before, that is Python, feature engineering, EDA, all those that we have learning before, but it is an ultimatum where we would be putting the data set into action of automation, or in the action of predicting something new or doing something new. So feature engineering, as I said, would be very crucial for this machine learning. And in this, in the ML ops which I would be coming before, we would see how we actually can create a cycle by going back forth to feature engineering, and then again deploying the models, then again checking the accuracy, and then again going back forth to the feature engineering. And this is a continuous loop until and unless we get the best out of our data set, or the best accuracy or precision, whatever metrics you talk about, until we get the best metrics out of our data set. So I would be covering this machine learning more in the next videos, and I would be covering all these topics which I am talking about in each and every video or in separate videos. So there is more to come in the future. So moving forward to our next stage of the roadmap, that is deep learning. So once we start learning deep learning, we would see that machine learning models are not that efficient in most of the cases, and deep learning is always a better way to handle the data. But why we are learning both the machine learning traditional techniques is deep learning techniques? Because the basics are very important. Once we know the basics of machine learning, it is very easy to understand or grasp the deep learning techniques. Yes, there is something different. There is the concept of neuron over there. There are different stages or layers in deep learning. We will definitely be learning those, but the initial understanding of machine learning, how the models are working, what is supervised techniques, what is unsupervised techniques, what are the different metrics we are using for the machine learning models to judge our data, this is very important, and this will definitely play a crucial role in our understanding for deep learning. But of course, deep learning has been made to outshine machine learning, and deep learning will definitely provide you a better result from machine learning, but we will be learning both with equal importance. So deep learning will not take much amount of effort, because deep learning is easier than machine learning to learn. But machine learning, the concept of deep learning is also dependent on machine learning, and our ability to judge data set, how many layers we should put, or which kind of models or activation functions we should go for, is important. Hence we would be providing almost 2 to 3 weeks to deep learning with projects, and this would be enough for deep learning. So once we are done up till this machine learning and deep learning, we'll be taking a break to do some projects and to do some case studies. And once we are equipped with these deep projects and case studies, we'll be moving to the stage where we can do text analysis. So in most of the beginner level data science projects, we will be covering some numerical based data sets, and then on we will be moving on to the text based data sets. Why text based database data sets will be moving on later? Because there is something called natural language processing that we need to do for the text based data set, because our machine does not understand text. To give out a meaning of that text and to make the machine understand of what text what we are providing, there is something called natural language processing. Simply the language that is being processed by the machine, natural language processing. So we will be learning the entire NLP. We'll be learning how to pre-process, how to do EDA, how to visualize, employ how to deploy the machine learning techniques, and how to deploy the deep learning techniques for NLP as well. So you can take it this way. First, we'll be learning the numerical based data sets. We'll be employing all the stages like first data pre-processing, then second EDA, which will include statistical methods as well, then feature engineering, then machine learning, then deep learning, and again for text analytics, we'll be learning all this. Yes, there are some different models or some extra models that we would be learning in cases of NLP like RNN, LSTM, bidirectional LSTM, RNN. But these are all very important and much dependent on the deep learning. So once we have the deep learning concept, learning this would be a very easy task. So this you can say is an extra learning, because once we see all this code, it will be very easy for one for us to understand at this stage what's going on, because we already know what deep learning is and how deep learning works. But we will not restrict ourselves to that. So as I was talking about, this data science has been transformed in such a way that today in this era we are much more dependent on models like transformers and generative AI. So we would be further moving in the NLP concepts to learn transformers and also few generative AIs as well. So once we learn all this numerical based dataset handling techniques and text based dataset handling techniques, we'll be moving forward on how to deploy this machine learning in production phase. So for that, we would learn different frameworks for production deployments like Flask, Bento ML, Daksha, Gradio framework. We'll be learning all this. So this I would be covering again in our separate videos. So all the different aspects I would be covering in the separate videos, but it is also very, I would recommend all you guys to join the classes, because in the videos I cannot cover all of them. I can only cover like 10% and 20% of them in a like very introductory form. But in classes it would be uh, you would be staying with peers, you can learn more, you will be doing projects. If any difficulties, you can ask me, you can ask your peers. So it is much more of a learning environment, like deep learning environment in the classes, rather than learning from YouTube. So once we are done with all this data science tasks, we would be going forward what's actually going on in the industry level. So in the industry level, they do not, so one data scientist does not do everything. So there are different engineers and groups for the different tasks. So it is always good to learn all of them at once and then explore one by one more. So let's, if we say, if you want to explore machine learning more in the industry, we call that machine learning engineers, what they follow as MLOps. So a machine learning engineer should undergo this MLOps to finally deploy their models, and we will be learning the same because this is some industry level applications, and we will be learning the same in our course as well. So in this MLOps, as I said, so first the feature engineering and machine learning deployment like design, then production level deployment, then model operation, and then we just iterate through. We just check again and again what is making our accuracy better. Then we will again deploy in the next release, and then again we'll check the operations. If there is any mistake, then we'll again go back to our initial feature engineering model deployment, and then again production level deployment, and again checking the operations of how our deployment is working. So this goes in a cyclic loop, and that's why I have presented this in a cyclic format. So here we will be learning various CI/CD pipelines. So GitHub Action, CI/CD pipelines, the Circle CI, Kubeflow, ML flow, and also we will be learning various industry level deployment techniques like AWS, Azure, GCP, and not only this deployments and CI/CD will also be learning some monitoring techniques like how our operations are performing with the deployment. So Grafana monitoring is a very important segment for that. So we'll be learning that as well. And further moving, and we will also be learning Dockers, AWS SageMaker. That is also these are also very important topics in the present day industries because this Dockers, containerization, Bento ML, AWS SageMaker are very DVC are very rapidly or very frequently used in our industries nowadays. And every machine learning engineer or deep learning engineer should know this. So finally, we will be ending with a list of different machine learning, deep learning, and NLP projects. So this will end our learning with the traditional methods, but this is not the end to it. As I said, we have catered to a lot of generative AIs and LLMs, and we'll be learning those as well. So OpenAI, LangChain, Gemini will also be covering that a bit, but not in our regular courses. It will be much of a internship based study. So you have to perform it. So it is not difficult to understand. These are some snippets of codes, and you can understand very easily once you grasp the machine learning and deep learning concepts in a wholesome way. So this will be very easy to learn. So this we will directly deploy in internship projects or industry level projects. So then again, so this is just like the deep learning and machine learning. We'll be also knowing how to deploy these LLM projects in various industry grades tools like AWS, Azure, Langsmith, Langserve, Hugging Spaces, and all those spaces. So I hope you have got the initial roadmap of how we would be performing or learning in 2024, and it is very crucial to learn these extra things because in the present industry we are only focused on how to efficiently use data science or machine learning and deep learning. Hence this new techniques becomes very useful, but again learning these new techniques requires a strong hold over the traditional methods, and we would be learning those as well. So thanks for your time everyone. So you can also check the upcoming videos. You can like, subscribe, and share these videos with your peers as well who is looking for a strong roadmap for 2024 data science learning. You can also join my regular courses. It is both online and offline for only Kolkata students. So if you want to join online, you can just visit our website www.sambhavlabs.com. You can give us a call on the number provided. You can also fill the form and we can call you back, and you can further enroll to our course. And yeah, so that's all from my side. I hope you have a happy learning for this data science. Just start learning. Don't waste your time anymore because this is the time where you should already be doing all these things, and there is no more time left to just delay on these topics. Just go forward and learn, and I hope a very great career in your upcoming future. Uh, Stay tuned as well to my YouTube videos, and I will be providing more informations in the future videos. You can check my descriptions for further website and contact related details. Thank you.